In this video, I'm going to show you how you can turn pictures from a tree into a 3D model. The basic process involves taking photos with your phone or a camera, importing them into a program called Meshroom, and then cleaning up the model afterwards with Blender. Keep in mind that the scan only really works for the main branches and not the whole tree. The first step is taking the pictures. You want to have at least 50, depending on how detailed the model should look. The more the better, obviously, but that could entail a longer processing time later on. For the pictures themselves, they should be unaltered, so no zoom or crop, and the whole approach works best if you take the photos during an overcast sky, so that there is evenly distributed light. The photos should be a bit brighter than usual as well, so that the details of the tree are much more prominent, and you get better masking result for the sky. The second step involves a program called Meshroom by the non-profit organization AliceVision. It is free and open source with no sign-up needed. The only downside being that it currently doesn't work on Apple computers. You can download it right here on their website. Alright, once you have Meshroom installed and open, the first thing you want to do is go to File and save it. I'm gonna call it 3D-Scan. And then you want to drag and drop your files into the panel on the left. If you've done everything correctly, a yellow icon should appear on the top left, which means it successfully read the metadata from your phone or camera. Then on the bottom you have your nodes. I'm gonna push this one to the side for now and add a new one called image masking. We use this to mask out the sky. So to the right, at the HSV parameters, I'm going to choose a blue tint with low tolerance. The saturation should be 0. The min and the max should be 1 because it doesn't matter. What's important is the value. It should be very high, like 0.95 or 7, I think is fine. Keep the invert checkbox and also add a bit of a shrink radius to get rid of some of the small like branches that might be confusing for the program. Then you want to connect the camera intrinsics SFM data to this one, and the output should go to the feature extraction mask folder and also the mask folder of the prepare dense scene. And right, once you have your settings ready, just go to image masking and right click compute. Here at the bottom, you can see the log, and if there is like an error message, it will show up, and sometimes it tells you how long it's going to take. When it's done, right click on the image masking node and open folder. You will get a bunch of pictures, and if everything went correctly, it should look something like this, where the tree and the ground and the surrounding structures are white and the sky is black. It didn't work perfectly, as you can see right here, so maybe I turn down the brightness value, this one to say 0.92, and then compute it again for better results. Once you've done that, we leave feature extraction as is, image matching as is, feature matching as is, and finally on structure for motion, we want to right click and compute. Once the process is done, you should see something appear on the top right. On the left, we can see actually every single image that we put in got a estimated camera, so that's good. When you click on these nodes, you can also see how long the process took. For example, feature extraction took 6 minutes and feature matching 8 minutes. Right, now we zoom in on this point cloud, and this is already a first indicator of whether or not we've done things correctly. And as we can see, the tree already shows up, so that's good. And you can also see it correctly identified the positions of the cameras. So I made a lot of photos from afar, some from like a mid-range, and also a few from the very bottom, and I photographed upwards. All right, now for the next step, we are gonna leave the prepare dense scene as is. At depth map, we want to change the downscale to something like 4. Don't put it to 1, and also only put it to 2 if you have a powerful computer. 4 should be fine for most. We leave depth map filter as is, and in the meshing node, we want to tick the custom bounding box and then double click on meshing. And as you can see, a box appears. At the top, I'm gonna quickly get rid of the cameras and also turn the point size down a bit. You can see that's what the tree is going to look like later on. I'm also going to turn on the trackball. And now with these little knobs, make the bounding box the right size. Now just go to meshing, right click, and then compute again, which is also going to take a bit of time. All right, once the meshing node is done, you should get a nice mesh at the top right. If you turn on the structure for motion or the point cloud and also the bounding box, you can see that it actually got the branches quite nicely, but there is still a lot of artifacts left at the top, which is why you want to clean it up later in Blender. To access this model, you just have to right click on the meshing node, open folder, and there you can find the mesh.object, which is what we need for Blender later on. But for now, we can save the project and close it. The third and final step is cleaning up the mesh in Blender. I'm actually gonna get rid of this because I don't need it. You can actually just drag and drop the object into Blender, then click on import. This is how it looks. As you can see, the bottom is very detailed, but the top is not detailed, obviously, because the camera couldn't see it. When you click on the mesh and then go to edit mode and to the faces and turn on X-ray, you can clean it up manually by selecting all the faces that you want to get rid of, then press X and delete the faces. The same thing works for the top, but there's actually a easier way. If you click on a face, a large one like this one, large compared to the other faces. Like these ones are very detailed, very small, and the less detailed parts have very large faces. Then you can go to select, select similar and area, and at the bottom left, compare greater and turn down the threshold. Now it actually selected every face that is bigger than this one. Now I'm gonna delete them again, and the tree looks much nicer already. To simplify it even more, you can go to the right, modifiers, and add the remesh modifier. Then go to smooth and turn up the Octree Depth to somewhere, I don't know, maybe 8. And keep the remove disconnected ticked on, because it gets rid of all those floaters that I don't want. Right, okay, maybe 9 is the perfect value. I'm also going to click on apply, and we're pretty much done actually. If you want to, you can go to sculpt mode and make some branches a bit bigger and more natural than they are now. This one, for example, is very weird looking. I'm gonna go to inflate, maybe turn down the strength a bit, and make the branch a bit bigger. Maybe I'm gonna turn up the strength actually. With the flatten or smooth tool, you can make the mesh look a bit nicer as well. Gonna turn down the strength again. Once you're satisfied, you might want to add a cube. I'm going to move it down, turn on X-ray vision again, and place it right here at the bottom. Maybe a bit higher. There we go. And by going to mesh, add modifier, and then boolean, and then take the cube as our object, then click on apply and delete the cube, we actually get a very smooth flat surface. Then by turning on the face snap and then place the cursor at the bottom of the tree, you can actually set the origin to the 3D cursor, and now it's much easier to move the tree about in other programs as well if you want to import it somewhere. By going to the location, I'm gonna move it to the origin, to the 0, 0, 0 point, and yeah, that's pretty much it. Now I can export it to maybe a .fbx or .obj and use it for whatever purpose